Uh, Dearest all my students, hello again, and I hope you are doing safe and healthy. Welcome to the new lecture in geotechnical engineering. Today I'm going to give you a lecture about lateral earth pressure, which is which is one of the chapters of the geotechnical engineering. As you know that we have different types and different methods for classification of the soils. So based on their physical property and chemical physical properties, and here I can give you another way to classify the soil based on their properties or shear properties. As you know that we have, let me go this way. As you know, we can classify soils based on their capacity or shear capacity. We have the soils that we have their properties based on the C, which is cohesion, and the phi, which is the internal degree, friction degree. So we have the soils that we have, it's called C soils, which means that those soils that they have phi equal to 0, it means that we have a C soil which is they have only the value of C, and as I told you, this is the cohesion factor, and it can be measured by kilonewton per meter square. So it will give you the cohesion force or the shear force that we have it for soil. So C soils, which means that like clay and salt, pure clay and pure salt, so they are not granular ones, so their phi is equal to 0. We have phi soils, and this soil is those that we have zero cohesion, which is means they are mostly granular. It means that either sand or gravel soil. Now usually we will have both in nature. We have the soils that they most likely have the C and the phi soils. It's called, they have usually the C cohesion, and they have the degree of the internal force or the phi soil. So usually we have this kind in the natures, and we can deal with this one. Now what if I have a soil like this? For example, I have a building here and a building here, and you want to build a structure here or a building here. What should we do? We want to build a structure here or a building here. So you have to do a kind of excavation. You want to do a kind of excavate this part. So I want to excavate this part. So what's going in this way? There will be the pressure, or there will be the soil. Here's the soil. The pressure here maybe will be more than the pressure here. Okay, so what will be here? It will be help this part to be pushed in this way and collapsed made in this way. Also this part will make this, so there will be a collapse in this in the first of all in this in buildings, and it will be here. Now we have different ways to control this one, because we have to control this way, and we need to have this built in here. So what should we do? Usually we have two things. First of all, is this wedge, or is this if we can say, when we have excavation like this, maybe you need to just excavate like this one and this one, and you can say you see that this excavation or this slope of the soil, it will be stable enough to build here your building. So if this slope, you may excavate and make a slope for this lateral pressure, and make this soil stable, so that this is not to be dropped down or falling in this way. Then this can be done by something called soil stability, or in other ways you can do, or you can do what? You can do it this way, or you can do your excavation here, your building here. You can make an excavation here, but you have to dig sheet piles here, sheet piles, or let me say retaining walls. So the retaining walls can be used just for preventing the pressure in this way to have to collapse, and you can build your building safely until you will done. And usually this retaining walls will stay in the soil, sheet piles or retaining walls will stay in the soil, and it will help for digging, or let me say excavation, more and more, until you get your new buildings constructed in a safe way. Now in this chapter we are going to study the effect of the soil that will help to push, or what kind, or what is the magnitude of the forces that can be on this sheet pile, or on this retaining wall. So I want to see what will be the force first, and what will be the location, because those two things, it will be very required to design, or to see the capacity also of this sheet pile, or this retaining walls, to see how much it will be. Now, so our purpose to study this, our study purpose of this lecture is to know what will be the pressure distribution on this wall, laterally, not vertically, the lateral pressure on this wall, and what will be the magnitude of this one, and so on. Now, based on that, we have a soil, and this will be going to be sheet pile, or let me say this is the retaining wall, and this will be the, for example, in this way. So if in case that the pressure in this way from this soil and this soil, so if the pressure from this type and to this type, this direction, what was let me say it's the same as this pressure from this direction, so it means that this retaining wall will resist both directional forces from both sides, but it stay in its position. Position means it's stay rest. So this is called at rest condition. So at rest condition, at any point here, we can say I can calculate the pressure that will go this way, and I can do the calculation and find the pressure that's going this way. And you know, we have to find the pressure, or let me say, in case that we have to know what will be the pressure or the force this way. So what should we know? Usually we have, if I will take an element here, let me make it more clear. So the idea is to find the pressure. Here's the pressure. Sorry. Yeah. This is going to be the pressure. Okay, now I want to see what will be the pressure, for example, here. This is the natural ground level, and this is the sheet pile or lateral and this is also the natural ground level here and there. So let me say this is A and B. So what we have here is I want to see what will be the pressure that this soil from the right hand, my right hand, will affect on this sheet pile. Usually we have the vertical pressure on this element, which is known as sigma vertical, will be the volume of the column of the soil on that one, and we took that one as a volume times the gamma of this the gamma of the soil. Now what will be the volume of the column? It means the volume of how much is the volume of the column of the soil that will affect on the surface of this element, which is, let me say, this is Z. So the volume of this element, if I took this element 1 by 1 cross section, so the volume is equal to 1 times Z. That is the volume of this column. Now the volume of this column will give you how much meter cube that we have of the soil above that point. Now this is the volume, and if I want to see how much is the force is equal to gamma times this volume. So the gamma, it will be in kilonewton per meter cube multiplied by the volume, which will be in meter cube. So that will be how much kilonewton will affect on the surface of this element. Now back to the meaning of the pressure. The pressure is equal to the force divided by the force, which is equal to gamma V, which is equal to Z times 1 times gamma. This is the force. So the sigma vertical is equal to the force divided by area of that element, and again this volume is Z times 1 times gamma over the area of this element is 1 by 1. The element is, this is the element is 1 by 1, so 1 by 1. So the sigma vertical is equal to gamma Z or gamma H. This is the vertical force that's coming from the top soil to the. My purpose to study what will be the laterally. The lateral, due to that vertical, it will be a lateral pressure, and this lateral pressure is called sigma horizontal. This sigma horizontal is equal to sigma vertical, as we know. As much as you have more deep clay, deep soil, it means the lateral will be more. So it will be a kind of a portion of this one. So this will be a constant times a sigma vertical, and this is called Rankine or lateral earth pressure constant. And because the forces from the right and the forces from the left are to be the same, so this and this one is in rest condition, so the sigma horizontal is equal to k naught times the sigma vertical, and this sigma vertical is equal to gamma z or gamma h at any condition. So this will be the lateral pressure at this point, and definitely there will be 0 here, and this will be gonna be distribution from this way. Also we will have a distribution from this way, and we can find at each value of z we can find the sigma vertical this way. This is in case that we have at rest condition. There is another case that we can say we can say that we have this way. We can say we have, this is the soil in this way, and we have a soil in this way. But now if the force from this way can be more than from that way, so it means that this sheet pile going to be moved in this way, so it will come this way. Now going this way, it means that it is an active case. It means the active case, it means this is going to be active, or the force that will be more than this one. So the force, that means I call this one F1 and this is F2. If F1 was more than F2, this means that we are in a case called active earth pressure. Then the active earth pressure will say, based on the same condition, the sigma active, which is the force that will having the lateral force due to the how it's equal to the same definition of the sigma vertical times a constant k, but now I will say this is as Ka, which is the active constant earth pressure. Now what that K active is equal, the K active, it will depend on the type of the soil, and definitely it will be let me say it will depend on the internal reaction of the soil. It means that in case that you have cohesion soil, then this Ka going to be 1, or it is not active way, because the definition of Ka is equal to 1 minus sine phi over 1 plus sine phi. So in case that we have, this means that this Ka will going to be definitely this will be going to be less than 1. This means that for the granular ones, the produced lateral air pressure will be less than the vertical pressure, but it will be high enough this way. Now in case that we have sea soil, it means that the phi will, when the phi is equal to 0, so this is it will be 1. So for c equal to 0, or for let me say when we have phi equal to 0, it means that for clay this K value will going to be its maximum. Okay, when we have 0 phi equal to 0, so it will be a 1. When we have c equal to 0, then it will be another thing. Now this is what we have. So this is the Ka, and by the way we have the K passive, which is another case. So we will just substitute the value of Ka here, and we will find the vertical or horizontal lateral earth pressure at any value. Again, this is sigma v, which is equal to Ka gamma z. then will be the value of the pressure and the depth. In case that the pressure on the from the right hand, let me say, in case that we have the pressure from the left hand was more than the pressure, so if this is F1, this is F2. If F2 was more than F1, means the direction of the movement of this sheet wire will be inside to this one. Okay, that means it is called passive case or passive earth pressure. Now the passive earth pressure, it will be very good for us, but it will make a kind of distraction to the buildings on the existing one here. So it will, for us, it will keep us, we can construct our building here, but it will affect on this one. Now, what is the magnitude of the lateral earth pressure? The lateral earth pressure, again, at any point is equal to K times sigma vertical, and this is going to be Kp. What is the value of the Kp? It is the 1 over K active. It means that the 1 over 1 minus sine phi over 1 plus sine phi, or it will be going to be K, it's equal to 1 plus sine phi over 1 minus sine phi, and usually it will be more than 1. So here's the three definitions. Again, we have only one other case, that in case that you have surcharge, it means if you have a Q value of force here, what will be the existing pressure, this one, sigma V. When I say this sigma V is effect of the column of the soil that we have on that element. In addition to that one, if I have Q, so what we have to do, we just add to this sigma V, we have to add its Q to it, and say the sigma horizontal will be a one that is Q vertical plus Q sigma V plus Q. So in general, or as a summary, we can say the general equation for the estimation the pressure or the distribution of the pressure at any type is equal to sorry for that one. Okay, as a summary for estimation the stress at any point, at any depth, I can say at any depth. For example, if I have the Z here, so if I have to find the pressure at this point, so what should we do? It is at the depth of Z. So for active pressure, sigma horizontal or sigma active pressure is equal to, in case that we have Q, so it's equal to Q, which is the lateral pressure, plus gamma, which is the gamma of this soil here, times what? Times the depth, which is the Z. Now this is the vertical column, this is the sigma V, and this should be multiplied by K, and then we have to have A, so I will multiply it by K active minus 2C prime square root of K average. So this is the equation that we are going to use and to find the active pressure at every point and different, and we make sure that when we have the boundary of 2, So it's like this, we have to take 1 here and 1 point here to find out the pressure due to, because the sigma is the here will be different than the gamma and here in this soil. So that the way that we are going to calculate the lateral pressure is to take the point above and just below the boundary to include the gamma soil here and the gamma soil here. Okay, this is for active, and for the passive I will go and calculate this the same way but with a little bit different. Here is just we have to add, not to subtract, add the CKP. So we are using these two equations in finding the pressure at any point. Now for this example, I have, for this one I have prepared for you this example. As you can see in this example, we have a surcharge, means that we have a building here or any structure here, and this structure will have a load on it. This is called surcharge, and this surcharge is having a load of 5 ton per meter square. 5 ton per meter square, it means that it could be 3-story or 3-floor building, which because for each residential or house buildings, we can say it about to be 1.2 ton per meter square. So for one floor, so this is means this can be a 4 building residential area there is here. Now if I have this one and we want to excavate for 5 meters depth and work here, so what should we do? We have to use a sheet pile. This is called a sheet pile or retaining wall. Now before that, we have excavated 5 meter and we go, the sheet piles tell us that below the 1.5 meter depth from this here, there will be a groundwater level, so that we have to be careful on this one. And after that, there is another 3 meters depth with a new soil. Then there we have a new soil. The new soil means the soil that is including water. Now what is the required? The required is to find the active. It means that we have the force from the right hand will be more than the left hand, the active pressure, and the passive pressure in case that the pressure from the right was more than the left. What should we do? We have to start solving this one. First of all, to solve this one, we have to first calculate. So the solution will be like this. First of all, we have to calculate the values of the values for each soil. So what we have to do, we have to find this soil, we have to find its Ka and Kp. So for soil 1, to find Ka, the Ka is equal to 1 minus sine phi over 1 plus sine phi, and it's equal to 1 minus sine 38 degree over 1 plus sine 38 degree. Let me check. Yes, the calculations. Yeah, just we have to bring the calculator. Here's the calculator, and for the calculator, 1 minus sine, where is the sine? Sorry, we have to with 38 the sine of 38 is 0.615, 6.615. So it's equal to 9.615 over 1 plus 0.615. So I can say 1 minus 0.615 is equal to point, sorry, 1 minus 0.615 is 0.38 divided by 1.615. So it's 0.238. 0.238. This is the Ka. What will be the value of the Kp? It's equal to 1 over Ka, which means 1 over 0.238. So it's 4.195. 4.195. So this is for soil 1. What about soil 2? Ka and Kp. So for soil 2 it's 1 minus sine 28 over 1 plus sine 28, and again 28, its sine is equal to 0.469, 1.469 over 1 plus 0.469. So 1 minus 0.469, sorry, 1 minus 0.469 is 0.53. 1 divided by 1.469. So here's 0.361. And what will be the value of Kp is equal to 1 over Ka, which means 1 over 0.361. And it's going to be, it's 2.766. 2.766. So the two values of Ka and Kv here is 2 that, and for the soil here. Now we are going to first of all calculate the value or the pressure distribution of the active case. So for active lateral earth pressure means that the soil that we have from the right hand this way is more than this way. Now for this one we have to calculate the or distribution of the pressure. So what we have to do first, we have to make sure that we have, for example, here the points that we have here. This is going to be first, for example, point 1, and this will be point 2, because here we have two different sources. I will just take above one, I will take below. This is going to be 1, 2, 3, and the final point is going to be here. So I will go and I will go and find the pressure sigma vertical at 4 points, point 1. Sorry, not vertical, I mean by sigma point lateral horizontal at point 1, sigma point 2, sigma at point 3, and sigma at point 4. This is lateral. So the definition of this one is, here's the sigma at any point is equal to Q, which is the surcharge plus gamma, which is the gamma of the soil that we have in that one, times the Z, it's the depth of the soil at that point, times the K active minus 2C square root of K active. Now for point 1, the sigma 1 is equal to Q Q, here's Q is equal to 5, which is ton per meter square, plus gamma soil, gamma is soil for soil 1, gamma is equal to 1.8 ton per meter square times Z. Sorry, this is gamma per meter cube, and the Z here, because the point 1 is just below the surface, so the Z here, it means 0, so that means times 0 times Ka. Well, here's the Ka for soil 1. Ka is equal to 0.238 minus 2 times the value of C, and for soil 1 C is equal to 0 times the square root of Ka, and the Ka here is 0.238. Now see, you can see this is going to be 0 as because we have 0, and this is going to be 0. So what will we have? We have only 5 ton per meter square plus this one. So it's going to be 5 times 0.238. This is ton per meter square, and then result will be equal to 0.238. So it's 1.19 ton per meter square. Now, yeah, 1.19. So means that we have, and this point, I can say here's will be 1.19. Okay, so if I have, this is 0.1, this is 0.2, and the depth is 5 meter. So 5.1 is here's 0.1, this point will be 6.5, because we have from here to there, this is 0.1, and 0.2 will be at depth of 6.5, and for point C is equal to 3 meters. This is 3 meters. So what will be the pressure at that point here? It will be 1.19 ton per meter square. This is the force at pressure point 1. Now I'm going to find the pressure at point 2. Point 2 is equal to the same way. Now remember that we are using the same equation. So the Q also 5 ton per meter square. This is the Q. Gamma, it means the gamma of this soil. Gamma soil 1, because point 2 still in soil 1. So the gamma of soil 1 is 1.8 ton per meter cube times the H is the depth of soil at point 2. So what will be the depth here? It's 5 plus 1.5. So this is the one that we need to calculate. So it's 6.5. So times 6.5 meter. Now the Q plus gamma H times K active, still we are using soil 1, which is the K is 0.238, minus 2 times the C will also 0 times the 0.238. Now what is the result of this one? The result is 6.5 5 plus 1.8 times 6.5, the result is 16.5 times 0.238. This is going to give you the pressure, lateral pressure at point, which is 3.97 ton per meter square. So it means this is 1.19. Now we have here 3.97. So this is going to be the pressure at this one. Now remember that we have to calculate the pressure from the point 3 just in this way, because we are in the different soil. So at point 3, which is just below point 2, the load will stay 5.5 ton per meter square, and gamma, here's the difference. The soil 2 have another gamma. This another gamma is gamma saturated. Now remember, this is a very tricky one. We have to not use the gamma saturated, we have to use gamma 2. Gamma 2 or gamma active is equal to the gamma saturated minus gamma water. Now here's we have to use the gamma soil saturated is 2 ton per meter square meter cube, minus gamma water is 1 ton per meter cube. So I can use 2 minus 1 is equal to gamma prime is equal to 1 ton per meter cube. Now, so instead of soil 1, I will not use 1.8, I will use 1 ton per meter cube. As I told you, this is gamma because we want to have the soil along, and this depth will stay 6.5 meter and times. Now here's the tricky thing, that the K active here, I'm using soil 2, so what will be the K active? It's 0.361 minus 2 times the C value. It means the soil has a C, so it means we have 10, and then it will be going to multiply by Ka, which is again square root of 0.361. Let me check this one. Start from 0.361. Square root of that one is 0.6, and times 2 times 10, that will be 12. So this is 12.01. Now go back to calculate the rest. 5 plus 1 times 6.5 is 6.5, so 10 plus 6.5, so it's 11.5 times 0.361, it's going to be 4, and now minus 12.01 will give you a negative, which means 7.85 or 7.86. Now what that called, how to do that? 7.5, remember that this is 7.85. now in this is 0.2.3, it will be the same here but in different direction. Now we have the lateral air pressure in this way here, it's 7.85, yeah, 85. So in negative, it means that it will be opposite this direction, so we have to do this way. Now here's the distribution of the stress from 1 to 2. Now from 3, now remember we need to know what will be at 4. I will go with the 4. So for 0.4, I will say it will be the 5 ton per meter square the same, plus here's 1 is the same, times what will be the z at 0.4. The z at 0.4, it will be 5 plus 1.5, which is 6.5, plus 3, which will be 9.5. So times 9.5 meter, times what will be the value of Ka, which is 0.361, minus 2 times 10 times 0.361. Again, this part is 12.06, so we have to just 5 plus 9.5, that's 14.5, minus 2 times 12.01, so it's going to be the 5 plus 9.5, this is going to be 14 point times 0.361, it's going to be 5.2 here, minus 12.01, so minus 12.01, so the result is minus 6.7. It's going to be minus 6.77. So means this is 7.85, then there will be here a little bit, this is 6.77. Remember, this is 7.8, so the distribution of the active pressure will be on this sheet, while here the total. Now, what will be the summary of this one? By the way, we have to add another force, which is the force of the we should add the water pressure on the sheet pile. Remember that you subtract the gamma from the part 2 of the soil. When we have a groundwater table here, we use gamma price, means that we didn't count into our calculation the water part. Now why we did this? Because we wanna add, then here's the level of the water. We have to add the distribution of the water, or the pressure of the water will be in this way. Okay, and we add it in this way. We can go and add this way. Now remember, if we add this way here, the water will be here. Okay, so what we have here, it should have to both sides. So what we have here is to have the water from this part, and then because they are symmetric, they will cancel each other. So that's why we didn't add the water here this way. Sorry, no, we have to add it here because there is no water here. We have just the soil here. So what we have to is to add the water this way. In another way, I can make it more clear here. Here is the soil. This part we added gamma H here, and here's the gamma H here, and here's the due to the having water here. So this part and this part adding together, A plus B will give you this distribution. Now the same way we have to add water this way. To add the distribution of the water pressure on the lateral, it will be like this. And remember, so this is 1, this is 0.2, which is the value 6.5 from here to 2.4. So this is 0.2, this is 0.4. What will be the pressure of water at 0.20 because it's just at the beginning? What will be the pressure at 0.4? It's about 3 meter of water. So the gamma here will be gamma H, gamma water times H, which is equal to 3 meter. Now gamma water is 1 ton per meter cube times the depth of soil on that point, 0.4 is only 3 meters. So what we have to add 1 times 3, so the 3 meters, so the pressure in this way will be 3 ton per meter square. So remember that we have to add this one here. So this is going to be the distribution of the active pressure on this way. Now next lecture I will continue and find out the passive pressure on this retaining wall and calculation of this one. Remember that we have also to when we are talking about the lateral passive one, it means the pressure at this part is more than this way. So we have to go with the points. Where is the point here? Should be A. I will use the letter instead of numbers to just make difference between active and passive. For passive, as I told you, the lateral wall, the left hand one will be more than this one. So I will go to find the pressure at point A and B, and because also we have difference of A and B, C and D, so we have to find at A and B, C, D, and next lecture we will make it more clear for you. Thank you very much, and see you next time. Thank you.